Hi everyone, welcome back to the problem solving for the thermochemistry part. Okay, so for this question, we is talking about if we combust 1 mole of the methane and it can produce the CO2, carbon dioxide, and water, and also the release that much of the heat. So here we got 1 mole of the methane can produce that much of the heat. And this is the link. Okay. Uh, and then here is talking about if we have 3 mole of the oxygen, then how much of the enthalpy of the reaction, enthalpy, the change of the enthalpy will react for this reaction. Okay, so first we need to set up the equation and also the enthalpy associated with the equation. Okay, so let's set up the equation. There's the methane gas is reacted with the oxygen gas, and when it's combust, it generates the CO2 gas plus the water. Okay, so the water I think is water vapor. Okay, and let's balance this equation first. That's the CH4, and we're gonna have 2 water here, and we have a 4 oxygen, so we have a 2 oxygen in front of the oxygen gas. Okay, so let's check whether it's already balanced. We have 1 carbon here, and 4 hydrogen. We have 4 hydrogen here, and the 4 oxygen. This is 2, and this is another 2. So we have a 4 oxygen. So it's balanced. And then we have enthalpy of the reaction here, and the enthalpy of this reaction is 802 kilojoule per mole. Okay, which means 1 mole of the C 1 mole of the methane can generate that much of the heat. Okay, so uh, for this question, you need to separate the question into 2 parts. First, first we have 3 mole of the oxygen. Okay, and you need to figure out how much more of the methane we need to react with the 3 mole of the oxygen, because we know the relationship between the methane and the heat, right? 1 mole of the methane can produce AO2 kilojoule per mole of the heat. Okay, and then you're based on how many mole of the methane you calculate. So what is the enthalpy associated with the mole, which this is a kilojoule. Okay, and for this part you need to use the stoichiometry. And here you need to feel this is we have a 1 mole of the methane can produce 802 kilojoule of the heat. Okay, so the kilojoule per the heat. Okay, so let's do this step by step. Actually, you can set up a long equation. Let me use another color. We first write down what we have. What's the question given? The question given is a 3.00 mole of the oxygen. Okay, so oxygen. You need to first you need to figure out, okay, based on the mole of the oxygen, we figure out what's the mole of the methane. In this reactions, we can figure out 2 mole of the oxygen can react with 1 mole of the methane. So we put the mole of the oxygen on the bottom. we put the mole of the methane on the top because we're looking for the mole of the methane. In this equation, we know 2 mole of the oxygen need to react with 1 mole of the methane. So after this step, you already figure out the mole of the methane. Okay, then the next step is you're going to figure out the mole of the methane and got the heat, enthalpy of the heat of the enthalpy. Okay, so we know the relationship between the 1 mole of the methane, which is 802 kilojoule. Okay, so we put the mole of the methane on the bottom, and on the top we're looking for the kilojoule. Okay, the kilojoule. So we know 1 mole of the methane need 802 can produce 802 kilojoule. Okay, and also this should be a negative sign. Okay, really don't forget there's a negative sign because this is release the 802 kilojoule per mole, so it should have a negative sign here, so don't forget there's a negative sign here. Okay, and then once you're set up this equation, you put it into the calculator. Okay, that's a 3 times AO2 negative divided by parenthesis 2 times 1 parenthesis. That's gonna be negative 1203. Negative 1203 kilojoule. Okay, so then let's check what's the sig. So this is a 3 sig, and this is 3 sig and 3 sig. So the final gonna be 3 sig. So the question that's gonna be negative 1.20 times 10 to the 3 kilojoule. Okay, okay. So this is the result. I hope you got right. Okay, thank you for watching it.